Here you can input the value of tributary area, number of floor, then approximate dead load and live load, automatic calculated with factor and all design calculation for your easy checking. Here you can input the value of tributary area, number of floor, then approximate dead load and live load, automatic calculated with factor and all design calculation for your easy checking. Dead loads include the self-weight of structural members, such as walls, plasters, ceilings, floors, beams, columns, and roofs. Dead loads also include the loads of fixtures that are permanently attached to the structure. Dead load is 75.35 kN. Live load is that can change over time, such as when people are walking around in a building. Anything in a building that is not fixed to the structure. In this example we have live load of 57.43 kN cals kilogram conversion for visualization. We'll assume that the floor load is 4.78533632 kN per square meter or kilopascal. And we have slab on grade thickness is 150 mm. The depth is 1.5 meter. Assume the thickness T is greater or equal to 400 mm. The compressive strength of concrete varies from 2500 psi, 17 MPa, to 4000 psi, 28 MPa, and higher in residential and commercial structures. In our example is 25 megapascal or meganewton per square meter. The yielding strength of reinforcement is 415 megapascal. We have 250 kilopascal ultimate bearing soil capacity. This value can be seen in soil report, and factor safety is 316 mm diameter bar. The unit weight of concrete is 23.544 kN per cubic meter. Considering soil bearing pressure, the KNA is equal to Q ultimate divided factor safety, so 250 divided by 3 equal 83.34 kilopascal. Nominal soil bearing pressure is equal to 83.34 kN minus 4.78533632 minus 23.544 times 0.15 for slab on grade pressure minus 20 times 1.2 for soil pressure above footing, so on so forth, so the Qn equal to 43.96 kilopascal. The factor load equal 1.4, dead load equal to 105.49 kN. The combination factor load is equal to 1.2, dead load plus 1.6 live load is equal to 182.308 kN. Then the ultimate soil bearing KNO equal to factored load over B square, KNO equal to 182.308 over 3.0625 equal 59.53 kilopascal or kilonewton per meter square. X equal to B over 2, minus E over 2 minus D, so X equal, as shown, then actual V shear is VOA equal ultimate soil bearing KNO time Bx by substitution, as shown, so actual shear is 59.53 times 1.75 times 1.75 minus 0.3 over 2 minus 0.209 equal 53.76 kilonewton. Calculating the ultimate shear capacity is VUC equals P times 0.17 times square root of FC times big B times D. By substitution the value, it is equal to 233.165625 kilonewton greater than 53.76 kilonewton. Therefore, OK. Since it is not OK, we use the formula shear VUC as capacity is equal or greater than VUA actual to calculate the depth D as shown. Checking the two ways, shear in actual is VUT is equal to KNO time B square minus E plus D square. By inputting the values, now the result is 173.53256932 kilonewton as actual shear. This is our width and length of footing equal to B, so punching shear width. This is our width and length of footing equal to B, so punching shear width is C square plus DD over 2 face of the column as per code, so become C square plus D. The same, the factored load and ultimate soil bearing counteract each other. The perimeter bow is equal 4 times C plus D, so bow is 1.536 meter. Beta is calculated as per code is the ration of long side of column to short side of column. The shear capacity at equation in the code is 0.75 times 0.33 square root 25 times 1536 times 84 times 1 over 1000 to convert same unit at other side equation equal 159.67 kilonewton. Shear capacity at B is equal to 0. Shear capacity at B is equal to 0.17 times 1 plus 2 over 1 times 0.75 times square root 25 times 1536 times 84 times 1 over 1000, so the result is 246.76 kilonewton. VUC at C is equal 0.75 times 0.083 times 2 plus 40 times all over 1536 square root 25 times 1536 times 84 times 1 over 1000 to convert kilonewton is equal 168.17 kilonewton. Least punching shear is 159.67 kilonewton, greater than actual shear, so not okay. If not okay, we will use the equation punching shear VUC capacity equal or greater than VUA actual, so by substitution VUC equals 0.75 times 0.33 times square root 25 times 4 times 300 times depth and divided by 1000 to convert kilonewton equal to or greater than VUA 59.53 times width of footing B 1.75 square minus 0.3 width square column plus D square divided by 1000 to convert D to meter. Using quadratic equation as shown, so we calculated depth D is 303.774514750541. To be depth D greater or equal to 303.78, so thickness is 398.78 plus 75 clear covering plus 16 bar diameter, so thickness of footing will be 398.78 to round off to 25. Just divide by 25, then round up, then multiply by 25, so it is become 400, then depth will be calculated to 305. So again, take the least of three equation required in code. Equation is 579.75, equation 2895.97, equation 3. So the least shear capacity is 579.75 compared to actual 171.42, so the shear capacity is less than shear actual, so it is okay. Check again for one-way shear. Again, using calculated depth D is 305, using shear actual equation is equal to 43.76, then shear capacity is equal to 340.27, greater than 43.76, so it is okay. As per drawing, the failure plane is here with distance x or width b over 2. The center of column toward x is c over 2, so ultimate moment mu is equal to kno times b times x over 2, so the mu is 27.38 kilonewton meter. Mu is equal to, follow the formula, 59.53 times 1.75 times 1 over 2 times 1.75 minus 0.3, all divide by 2 to the power of 22, so the mu is 27.38 kilonewton meter. Use this formula to calculate A based on ultimate moment is equal to or less than P times 0.85 times Fc times AC times D minus A over 2. And the strain of concrete greater than 0.005 mostly, and Fs of steel is greater the phi, and P is 0.90. Ultimate moment is 27.38 times 1000 to power 2. To convert to kilonewton millimeter, equal or less than 0.9 times 0.85 times 25 times A times 1750 times 305 minus A over 2. So to calculate A using quadratic equation, A is equal to 2.7. Hashtag div/0. Hashtag div/0. Hashtag div/0. As per diagram, compression C is equal to tension T, then the C is equal to 0.85 times Fc times A times B is equal to as area of steel times phi, so as is equal to 0 mm, and as minimum from code is equal to 1395.73, therefore us as 1395.73 mm square. To calculate number of bar is equal to as over pi over 4 times d times b to power 26.95, round up to whole number, becomes 7 NOS of 16 mm diameter of main reinforcement bar. To spacing of rebars 1750 equals 7 number times 16 bar diameter plus 275 clear cover times 2 both side plus 7 number minus 1 times SSO spacing is equal to 248 mm as per the code must be lesser to 3, which is 1196.34 and 450 mm, so it is okay. For temperature or shrinkage bars, same with the number of main reinforcement above, so 7 numbers 16 mmo shrinkage or temp bar spacing is 248 therefore use 7 number 16 bottom bar. For temperature or shrinkage bars, same with the number of main reinforcement above, so 7 numbers 16 mmo shrinkage or temp bar spacing is 248 therefore use 7 number 16 bottom bars both ways.